Hello everybody, it's Miss Pariseau here. I wanted to just take a few minutes if you wanted to go over your Unit 8 exponential functions test. So number one, no one really had any issues with, but just in case, exponential decay. So you're looking for a fraction, so you're looking for a number between 0 and 1, and the only one that was there was letter C. All right, so we seem to struggle a little bit more on number 2, and I think the key piece of information is right here, is when D does not equal 0. So that means that this is plus 3, minus 2, whatever. You have a number here. So there is a number right there in that D position. So which one is true? The A value indicates a horizontal reflection. No, it was never a horizontal, it's always a vertical, so that is not true. The A value represents the y-intercept. Remember, it can, but that's when D equals 0. So if you thought it equaled the y-intercept, you're correct, but it's when D specifically equals 0. So that's why that one is actually not true in this case, all right? The D represents a vertical shift, and remember that's kind of like that's our asymptote, so it means that we're moving up or down, and so that is the true one. It is not a horizontal shift. That would be in the parentheses with that X there. Okay, all right. Number 3 kind of ties in with number 2 about that whole y-intercept piece. So again, if you a great strategy is just plug this in. If you wanted to, like when you plug in 0 for x, you get out a 5, right? If we plug in a 0 here, that's 2 times 1, which is 2, so that didn't work. If we plug in a 0 here, we get 5 times 1, and that works. If we plug in a 0 here, we get 1 plus 5, and that's 6. And if we plug in a 0 here, we do get 5, but it says growth rate, and so this is linear, so we need the exponential one, which is B. Okay. And then for our class, we didn't have any issues with this, but in case you just made a quick guess, another good strategy here is plug in the value at when x is 1 and find out where it is and see if it matches up with the graph. So when x is 1, 5 times 0.5, well, that's 2.5, which that's not the correct one. When x is 1 here, that's 3 times 2, we should get 6. That did not work out there. When x is 1, we get half of 4, which is 2. And then when x is 1 here, oh, you could have even done 0 here. Well, no, 0 would actually give us the that y-intercept there. So I would kind of check out here and check that point. But also notice that this is a decay. And this is actually showing a growth. So that's a good way to say that that does not represent. So C was the correct one there. All right. Here in this one, basically plug in 2 and negative 2. If it's a negative 2, remember that's going to flip that. So it's going to really be 4 times 2 squared, essentially. Because a negative exponent, right, it's 1 to the negative 2, 2 to the negative 2. So they're not happy there, so it's really 2 squared over 1 squared, which is 2 squared. So that 4, when it's f of negative 2, it would be 16 equals 16. And f of 2, well, 1/2 squared is 1/4 times 4 is 1. So you're comparing 1 and 16 there. So that's why B was the correct answer. Number 6. So this one was one of our lower scoring problems that we got. And I think it was just because that, remember, it's not f of 9, right? F of 9 would mean when x is 9. But this is saying which one can you not have a result be 9, right? So, I mean, you could have plugged in numbers and tried it out, but basically, right, is there a way for this to, if I have negative 1 times 3 to whatever power, it's always going to result in a negative. There's nothing to do to get rid of that. Like there's no number I can put in for x that's going to turn this whole thing into a negative value. So there's no way for it to become a positive 9. Whereas here, if I put a 2 in, that's 9. So that one works. Here, same thing, right? There is a chance for it to be a negative 9 because I'm adding, or a positive 9, because I'm adding 27 to it. So this might result in negative, but when I add 27 to it, it could end up being a positive 9. And then the same thing here, this would just be negative 2, and I'd flip it. So that's why A is the answer for this one. Again, because there's no value of x, no matter if I put a negative or a positive, that is going to undo that negative sign out in front. All right, number 7. You did have to take a look at your x's from 4 to 5. Again, I like kind of having it in, 4 is paired with 12, then 5 is paired with 3. So if we look at it in this way, right, we can see we're going from 12 to 3. So 12 times what gives you 3, and that's going to be 1/4. So you had to pay attention to the which way you were going. So it's never going to be a negative, right? Okay. In this case, because again, we're talking about what's the rate rate of growth, or that multiplier that we're doing. So here it is a decay of 1/4. Number 8, I'm not going to go over. We had 100% get that correct. Number 9, we also had 100% get that one correct. And as well as number 10. So if you wanted to follow up with me, you can check in about those. If you maybe were like, well, I just guessed, I'm not really sure why I got that right. Let me know. Okay, again, we did pretty good on this one. We see that it's depreciated 32%, so that means it's lost 32%, which means if it's lost 32%, then what it's worth is 68%. So this is what it's lost, right? This is what it's actually worth. It's worth 68% of its original value. So that's why if our starting value is $3.99, we want the rate of decay to be 0.68, because again, remember it's 1 minus 0.32 to the x and that initial value there. Okay, and then number 12, I'm wondering if maybe we just struggled with, because it didn't say that he bought it in 2021, which is the year we're in. So I could see that if we maybe used the wrong exponent here. But here, it cost him $115. He bought it for $115. That was the result after it's depreciated, right? So I know that some of you are thinking, well, I'll just work backwards and do 115 and do 1.11 and be like, hey, it's increased by 11% each year for 15 years. But unfortunately, it's not the way. It's not as easy as just like undoing that in exponentials. It doesn't work out that way. Okay, so you have to actually think like, okay, what was the cost? Okay, and then it has depreciated, right? So it's by 11% each year, so minus 0.11, and that was for a total of 15 years, and you end up getting 115 because that's what Mr. Irvin bought it for. Okay, so we kind of want to take that's what our equation was, or if you just went ahead and did that math right there and said it was 0.89, that's fine. It's just unfortunate. I understood what some of you guys are trying to do is like, I'm just going to work backwards. If the initial value is 115 and I increase it by 11%, I should work my way backwards to the original price. And unfortunately, it's not one of those easy undo situations such as adding and multiplying are. Okay. So that was the equation we were looking for. It did say round to the nearest dollar. Just be careful with your rounding. When you put it in terms of money, it does come out to here. So if you're rounding to the nearest dollar, $660 is what we were looking for. If you left the money, that was fine. But if you did do some rounding wrong with your with that, I did take off. Okay. All right. We did struggle some here. Okay, so we're taking a look at, this is a relationship about interest being owed on the credit card. So again, remember you had the formula there that it's, if you go back to the main page, right, the growth formula is this. So it's 1 plus whatever the rate is. So that means that this, it's 1 plus 0.276 to the x, and this, our 424 is our starting value. So it says choose which ones are true. The initial amount with 424, yes, that is true. It's in the A position. The function has an asymptote at 12. No, I'm not even sure where we would get that from if that was a selection, so no. The interest charge on the credit card is 2.76%. No, again, if we were to change that into a percent, multiply it by 100, it's actually 27.6%. So if that decimal had been here, that would be correct, but it was off by a place value. Okay, then for D, basically plug in 6 for the x right here, and when you do that, you do get this value, so this one is correct. And the domain of the function would be described by the total amount of money owed. No, that's what the whole function represents. And it says the relationship between the total amount of money owed on a credit card, f of x, that's the whole thing, and the number of months since a payment was made, x. So x is the months, the timeline, like how long have you been making payments on it. So that's the time. If this said the range of the function, then you'd be correct. But E is not correct either. So it was A and D that we were looking for. Okay. Number 14, we had 100% get that one correct. Okay. All right, so same thing, kind of reasoning through this, understanding the parts here. Okay, so here we have our formula. The rate of growth is 1.0005. Well, if you put this into the calculator, this does work out. Yep, it adds up. So if you did 0.002 divided by 4 and add it to 1, this is what you get. So that is true. So that's a true statement, but we're looking for false. Okay, so let me put it that it's over here because it's not the one I want to pick. I want to pick the false one. So the domain of this function is 0. Now, we are so used to thinking that it's got to be a parenthesis, but domain, right? That means that maybe I started this at some point, right? There was an initial starting place. So my time after 0 years, I could put in a 0 here. So it is included. So that is true. That is still true. The interest is compounding quarterly. That's true because I'm dividing by 4. I'm dividing by 4. So here, it must mean this one is the one that is not true. V of 30 would calculate the number of years it would take to equal $30. No, if it's inside, notice what's inside is T, that's time. So that would be after 30 years. So this is the one that is not true. Okay, and then for our last one, hopefully to get this in before my time runs out, okay, we have basically what you needed to do was you needed to take this y value here and divide it by that y value to get your rate, which is 1.25. So that essentially means that, you know, okay, it's growing by 25%. So here's your equation, right? And here's the initial value, right? At time 0, it was 5. So $5 was what you bought the card for. And then it's growing by 1.25 for X amount of years. So there's your equation. And then you needed to plug in 26 for this one. And you would get $1,654.36. Okay, so again, when you've been given a graph and it's exponential, you need to divide the y values, okay, kind of like the second y value by the first, because we can see that it's a growth. If you flip-flopped it, you would have gotten 0.75, and you'd be thinking it's a decay. All right, Let me know if you have questions.